explains it better. Yeah, there is a reason. Logan.
For the first interval that we just did, or A, is there shading on the right side of point B or not?
The right side of which point?
On the right side of point B, like on the right side of the curve. Is there shading there or not?
It goes all the way to the axis.
Means like with a curve.
Above, yeah.
Like,
So,
is it in the,
Right there,
is it
go down,
inside
go down.
the curve? Like,
Right there, at the D, look at the D.
Point at D
Between
and a little
D,
bit
C.
in.
Just look at the D.
yeah, the whole thing, it's the whole area from here down.
Okay.
Everything that I have shaded.
So it's not just like to the left, we can't see the shading.
No, to the right, I don't think there should be.
No, it's everything to the, all the way down, guys.
All the way down.
Yes. Yes. All the way down, yes.
Yeah, like to the right of point D, like.
Yeah.
Yeah.
That's
Yes.
Like,
Yes, it's the entire area, including down. It's just the integral of this curve. This is the curve I'm integrating in the first part, this here. What- yeah.
Should it be on the side of the
Where did I write the VA? Here,
Why? How did
GA. That's the, from P reference to PA. It's just the integral of this curve. This is what I'm integrating here.
Oh.
Yeah, so erase
So it's
this.
the area, all the area under this curve. So that includes the whole thing here.
Okay, I guess that makes sense.
Okay? Like from A to B is everything underneath this arc.
Ah.
So that includes the whole orange thing. That's why I brought my color markers. Okay. The next one is from B to C, but normally that would go from right to left. The area underneath is going from left to right. What can I do? Integral from B to C is minus integral from C to B. So I'm going to rewrite that as minus integral PC to PB. So this I can write as minus integral PC
That's how you get that.
to PB.
That makes sense now.
And now you see why I wanted to do it separately for PB.
I think you get the whole class.
So I'll need another color. I've got blue. So the integral from PC to PB is what is under. I'll tell you what, let me color those guys with a color. So this was the red. This is what I'm integrating below the red. This is what I was integrating below the orange. This is what I'm integrating now below the blue. So the integral from C to B is this. Let's call this area here, let's call this area here A1. Okay? You can see that the orange minus the blue is A1. You see that? This is the red. Okay? Here is the red. This is the red. This was orange. And this is the blue. And I hope you can see that orange minus blue is the shaded area. How are we doing? Ricardo, okay? Jeremy, okay?
Value, if you did it from B to C or from C to B, would that be the same value, but one way is negative and the other is positive?
Yeah.
Okay, thanks.
But- So this, the difference between the two is A1. Now, we're almost, now let's do GE. So let me first write this. So we have that GC, we showed it, is equal, this is what? This is GA. So that's GA plus A1. That's what I showed you. Let's calculate now G. G is all the way to here. This is going to be GC plus the integral from PC to PD plus the integral from PD to P. C to D goes in decreasing direction. So to make it in increasing direction, I'll flip it. So that's minus integral D to C. PD to C. Okay, let's, I guess I don't have enough colors to use different color for everything. I have a green color, but that's, no, I have yellow too. I don't have enough colors. Okay. Good, I brought the right colors. Okay, green will be a challenge, but D to C is what is underneath the green line. So from here to here, this is D to C. Carmen, okay? So that's the green one. And finally the yellow is D to E. So, what is, actually let me do something, let me put a parenthesis here. So this is correct, but let me put a parenthesis here. If I put a parenthesis, it becomes plus, and this becomes minus, putting a parenthesis. With me? Instead of writing minus plus, I put a minus with a parenthesis in front, so that this is now plus, and this is minus. Rob, okay? Enrico, okay? So, what is green minus yellow? Go back here. Green is the whole thing. Yellow is this thing. What's the difference between green and yellow? It's going to be this area right here. And let's call this A2. Okay. So that is equal to A2, this difference. So we get that GE is equal to GC minus A2. So, putting them together, we get that G that must equal GA GC is GA plus A1 minus A2. And what must we have between G and GA? Equality. Since at P vapor, G equals GA, follows A1 minus A2 must be 0. In other words, A1 equals 0. So if I give you in an exam a diagram like that, how would you find the vapor pressure? You would have your trusty ruler and move it up or down, until you can find equal areas, and draw that, and you find the vapor pressure. Yes?
Just see.
Yeah, it's not a bad idea. Oh, I forgot in one part, the past exam, I didn't have the attachment. It was a diagram like that with little squares paper, so you could count areas by counting squares. Okay, I realized in the old exam problems I posted somehow was missing a graph. That was the missing graph. It was something like that with little boxes to show you. Okay. All right. So we could be doing that. But of course, if we have software that creates this graph, we can do something different. Yeah, we could somehow manipulate the software to try to get equal areas, find a line with equal areas, but we can do something a lot simpler. We can actually have the software calculate the molar Gibbs energy. Calculate the Gibbs energy for the vapor and for the liquid, and when you have equality, that's your vapor pressure. That's how we will calculate vapor pressure for the most part in this class. And so, with that, good time to introduce the software of this class, or other than Unison. So, this is a straightforward VBA program.
Yeah, you're just adding.
So I didn't bring my computer so I can download it from the web. If you go to the class website, turn your computers and go to the class website. There are two pertinent things to look at. The program itself, so it shows up. Question?
Yes, but I'll ask you after class. I think I just don't not quite understand how you get for G and it was C and you had G A like plus A1. I'm adding the integrals and getting something different in my head. Once I spend time to actually do it, I'll figure it out.
Yeah, I have the same question.
Okay.
I'm gonna ask you after class. We don't have to go to class.
So if you download the software, we go through a little bit of it, but we also go through the program itself. Oh, and I need to I need to add a low macros for it. So file, functions, class center settings, macro settings, enable macros. I don't know if it belongs to line, but yes. Okay, so you have a user-friendly interface, a nice coloring, and said that I admit when I first wrote it was all one color. So that's one of the X theories improved on it. But information you will need to run this. You need to get, for example, from Unisim, you can get critical temperature, critical pressure, the eccentric factor, and Unisim will also give you the molecular weight. Also on Unisim, you find the coefficients for CP star. Note that A is not, the Arrhenius coefficient A is not being used, only the B, C, D, E, and F. And you're going to be specifying a temperature, you're going to be drawing the curve for a specific temperature. So let's see, for what substance is this? 28 molecular weight. May have been what? It may have been nitrogen. It may have been no, it's not ethylene. C2H4. Right? That's 24 plus 4, 28. Yeah, so I think it's probably ethylene. But so you specify a temperature, and in this case, critical temperature is what? 9 degrees C. So this is below the critical temperature. You specify a beginning pressure and an end pressure. And then you simply click run. And you can say, here is the pressure versus V hat. This is the diagram we've been talking about. If I go back and run it, let's say if I run it to temperature 15, let me change that, or not the critical, let me change the temperature to 30 degrees C. 30 degrees C is above the critical, right? What should you see? Let's run it. Okay? Above the critical, we don't have a vapor pressure. So if we go back to -10, or let's use -20, well, we have a critical. There's nothing. I'm just showing you. You can just look at what I'm doing. I'm just showing you what happens at different. And by the way, one thing you notice, and a reason the graph, of course, will stop is that we cannot have negative pressure. Okay? So sometimes the minimum would have been at the negative pressure. So we could find vapor pressure by trying to see where we have equal areas at the straight line. But instead, we can be calculating what is the Gibbs free energy. And where I have multiple solutions, I will have, for the same pressure, multiple Gibbs free energies. So in this case, I start at pressure 0.1, and in this case, so 0.1 is here. You can see at 0.1 I already have multiple. It's at the region where I have multiple. So you'll see here in the table output that you have, look at the left for the pressure. So if a pressure appears 3 times, there are 3 solutions to the cubic equation. The middle one is one that is never anything useful, so this is blanked out. So if you see a blank in the output, that's the one that would have given us the unstable KT negative solution. Let me go back to -10 where you don't have it from the beginning. Let's go back and run it at -10. So I'm changing the temperature back to -10. So if you look at the -10 diagram, you can see at the beginning there should be only one solution. Let's look at it. At the beginning you see only one solution. Where do you start vapor? When you start having multiple solutions? When I start seeing blanks. So that a lot of here. Okay, so right now you can see at pressure about 177 or 178. So if you look at the graph, 177, 178, you can see here is 3, here is 2, here is the point 177, 178. So now I start having 3 solutions. Okay? But look at the table. You have also the molar volumes. So here are the molar volumes. Here's the pressure, there's the other pressure. You have the molar volumes. Which one is vapor, which one is liquid, the top or the bottom? These are the molar volumes. So top is what?
Liquid.